How are diamond cutting discs made? Hey, Engineering Pro! Today we're going to unveil a secret used in many construction projects, renovations, and even artistic work: the diamond cutting disc. These tools that seem simple at first glance are true wonders of engineering, capable of cutting even the hardest materials with impressive precision and efficiency. So what exactly are these diamond cutting discs and why are they so special? A diamond cutting disc is essentially an abrasive tool designed to cut extremely hard materials such as concrete, asphalt, granite, marble, and even some types of metal. The secret to its ability lies in the use of industrial diamonds, which are the hardest materials known to man. Unlike common abrasive discs, which wear out quickly when cutting dense materials, diamond discs use the superior hardness of diamond to scrape and remove material instead of simply grinding. This results in cleaner, faster cuts with much less effort. But how did we arrive at such advanced cutting technology? The history of diamond discs is a reflection of humanity's quest for more efficient tools. For a long time, cutting stones and hard materials was a slow and laborious process, relying on metal tools that wore out quickly. The real revolution began with the development of synthetic diamonds in the mid-20th century. Before that, natural diamonds were expensive and scarce, making their large-scale use for industrial tools unfeasible. With the ability to produce diamonds in the laboratory, a new horizon opened up for the manufacturing of cutting tools. From then on, engineers and metallurgists began to experiment with ways to incorporate these diamonds into metallic matrices, giving rise to the first diamond cutting discs as we know them today. It was an advancement that transformed entire industries, from construction to mining and gemstone cutting. And what is the basic structure that allows these discs to make such precise and efficient cuts? The structure of a diamond cutting disc is surprisingly simple in its design, but complex in its execution. It is made up of two main parts: the substrate and the cutting rim. The substrate is the body of the disc, usually made of high-quality steel. It is responsible for providing stability and strength to the disc, ensuring that it does not deform or break during use. It is a fundamental part for the safety and durability of the disc. The cutting rim, in turn, is the part where the diamonds are embedded. It can have a continuous rim, a segmented rim, or a turbo rim, depending on the type of cut and the material to be worked on. It's in this cutting rim that the magic happens, because that's where the diamonds come into contact with the material, performing the cut. But how are these small and powerful diamonds attached to the disc so securely? The attachment of the diamonds to the disc is the heart of the manufacturing process and is mainly done through a method called sintering. Sintering is a metallurgical process that involves compacting and heating metal powders, in this case mixed with industrial diamonds, until they bond together and form a solid piece. The process begins with the selection of metal powders such as cobalt, nickel, iron, and copper, which will serve as the matrix that will hold the diamonds. These metals are chosen for their bonding properties and for how they wear down, releasing new diamonds as the disc is used. Industrial diamonds, which are smaller and of lower gem quality but perfect for cutting, are carefully mixed with this metal powder. From there, the process usually follows two main steps: cold pressing and hot pressing, or sintering itself. In cold pressing, the mixture of metal powder and diamonds is placed into molds and subjected to high pressure. This compacts the powder, giving it an initial and cohesive shape, but still without final strength. Next comes the crucial step: hot pressing or sintering. The preformed piece is then heated to extremely high temperatures, usually between 700 and 1200 degrees Celsius, while still under pressure. Under these extreme conditions, the metal particles fuse and bond to each other, firmly encapsulating the diamonds within the metal matrix. It is at this moment that the cutting segment acquires its density, hardness, and most importantly, the ability to securely hold the diamonds during cutting. After sintering, the diamond segments are attached usually by laser welding or brazing to the steel substrate, forming a complete disc. Precision in this process is vital because a weak weld or a poorly formed matrix would compromise the entire tool. But what are the different types of diamond discs and what is each one used for? The variety of diamond cutting discs is vast, and each type is optimized for a specific purpose, ensuring better performance and finish for different materials. The three most common types are segmented discs, continuous rim discs, and turbo discs. Segmented discs are easily recognized by the slots or segments along their edge. These slots serve to dissipate the heat generated during cutting and to remove dust and debris from the material. They are ideal for more aggressive and faster cuts in materials such as concrete, masonry, bricks, and asphalt, where a superfine finish is not a top priority. Continuous rim blades, on the other hand, have a smooth and uninterrupted edge without segments. This feature allows for an extremely smooth and clean cut with minimal chipping. That's why they're the perfect choice for materials that require a high-quality finish, such as ceramic, porcelain, marble, and granite. They are usually used with water cooling to prevent overheating and ensure an even more precise cut. Finally, we have the turbo blades, which are a kind of hybrid between the previous two. They have a serrated or wavy edge, which combines the cutting speed of segmented blades with a cleaner finish than those. They are versatile and a good option for a variety of materials, including concrete, rocks, and some types of ceramics, offering a good balance between speed and cutting quality. Choosing the right blade is crucial for the success of the job and for the operator's safety. And where can we see all this technology in action in our daily lives? Diamond cutting blades are true unsung heroes in various industries and applications. In the construction industry, they are indispensable for cutting reinforced concrete, making grooves in asphalt for pipe installations, and cutting bricks and masonry blocks with precision, and even for demolishing structures in a controlled way. Without them, many of the construction projects we see today would be much more time-consuming and costly. In the decorative stone industry, such as marble and granite, diamond blades are the main tool, cutting large slabs, shaping countertops, floors, and coverings with flawless finishes. The beauty and precision of cuts in natural stones that adorn our homes and buildings are, for the most part, thanks to these blades. In addition, they are widely used in the installation of ceramic and porcelain tiles, ensuring that each piece fits perfectly. Even in restoration and artwork, where precision is essential, diamond blades have their place. In some specific applications, diamond blades with special metal alloys can be used to cut hard metals, such as cast iron or ductile iron pipes, showing the versatility of this technology. It's fascinating to think that such a robust and effective tool relies on tiny carbon crystals to do its job so masterfully. With so many options available, what are the advantages of using a diamond blade instead of other cutting tools? The advantages of diamond cutting blades are numerous and justify their widespread use in professional environments. First, durability is a key factor. While common abrasive discs wear out quickly and need to be replaced frequently, diamond blades, due to the extreme hardness of diamonds, have a much longer lifespan. This translates into time and cost savings in the long run. Secondly, the efficiency is unmatched. They cut through hard materials much faster and with less effort from the operator, increasing productivity on the job site or in the workshop. Precision is another advantage. Diamond blades provide clean and straight cuts, minimizing material waste and ensuring a high-quality finish. This is extremely important in jobs that require perfect fits, such as installing floors or countertops. In addition, the versatility to cut such a wide range of extremely hard materials is something that few other tools can offer. But are these blades really the solution to all cutting problems? Or are there precautions and limitations we need to be aware of? Despite all the advantages, it's essential to understand that these blades are not a universal solution and require specific precautions to ensure their effectiveness and, more importantly, the user's safety. One of the main limitations is that they are not suitable for cutting soft materials, like wood, plastics, or common ferrous metals. For these materials, abrasive discs or saws with specific teeth are more appropriate. Using a diamond blade on soft material can cause overheating, premature wear of the blade, and even accidents. Another crucial point is the need to choose the correct blade for the material to be cut. Using the wrong blade can result in inefficient cutting, damage the material or the blade itself. Cooling is also an important factor. Many diamond blades are designed for wet cutting, that is, with water, which serves to cool the blade, extend its lifespan, and reduce dust. Ignoring these recommendations can lead to the blade overheating, warping, and loss of performance. And of course, safety is paramount. Always use personal protective equipment such as safety glasses, gloves, and ear protection, and follow the manufacturer's instructions for both the tool and the blade. The engineering behind these blades is incredible, but respecting their limitations and using them correctly are essential. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be mentioned in our videos. And if you're curious to learn more about the courses we recommend, scan the QR code here on the side or click the link in the video description to access several opportunities to develop various skills that will make a difference in your career. So, have you ever had the chance to use a diamond blade in any project? Which material do you think is the most impressive that it can cut so easily? Leave your answer in the comments because I want to know. Here on the side, there are two interesting video options that you need to watch to expand your knowledge and satisfy your curiosity. To support us, like subscribe, turn on notifications, and consider becoming a member. That's it, engineering enthusiasts. Take care, and I'll see you in the next video.